So we're going to spend most of the rest of this course talking about the standard normal distribution and the normal distribution curve. So the normal distribution is a symmetric bell-shaped curve. If you've ever heard things about having a bell curve, they're talking about a standard normal distribution. And it tends to be that many variables that we measure have a bell-shaped distribution where we have in the middle the mean, and then the values disperse around it, okay? And it turns out that most of the values are within 3 standard deviations below the mean and 3 standard deviations above the mean, okay? And because this is so prevalent, what we see is for any curve that's normally distributed, we can talk about the standard normal distribution where the horizontal axis is labeled with Z. We call those Z scores, and we're going to talk more about those in the next module. And Z scores are simply a measure of how many standard deviations a value is from the mean. So the mean is in the middle, and that's 0 standard deviations from itself. And then as we move to the left, just like moving on a numbered axis, we can have 1 standard deviation below, 2 standard deviations below, or 3 standard deviations below. We can have 1 standard deviation above, 2 standard deviations above, or 3 standard deviations above, okay? And as we discussed, for continuous probability distributions, we can find probability by finding the area underneath a probability density function. And so that curve is the top of our probability density function. And so when we think about the area underneath the curve between different values, that area corresponds with how likely the event is about to occur. The more area, the higher the probability that an event occurs. Okay, because our curve is symmetric, we know that 50% of the area lies below. We have a probability of 0.5000 of being below a value of 0, and we have a probability of 0.5000 of being above the mean, okay, or above 0. Okay, so I'm going to introduce a little bit about the standard normal distribution here and the normal distribution here, although we're going to continue that on again in the next module. At the end of this module, we'll talk about shortcuts and ways that we can simply approximate the probability of events using a rule of thumb associated with the standard normal distribution. So a formula that we need to get used to is this idea of the Z score, which is a measure of how many standard deviations a value is above or below the mean. So to figure it out, we take the value we're interested in, we subtract the mean from it, and we divide by the standard deviation. So if a data set is approximately normal, it means that it basically follows the standard normal distribution, has a mean value of 6 and a standard deviation of 2. What's the Z score for a value of 4? Plugging into our formula, we have 4 minus our mean, which is 6, all over 2. Because of order of operations, we evaluate the numerator first. 4 minus 6 is -2. -2 divided by 2 is -1, right? So that Z score is just telling me that my x value of my x value of 4 is equivalent to a Z value of -1. Whenever our Z values are negative, we're below the mean. When our Z values are positive, we're above the mean. Because everything involving normal distribution revolves around knowing the mean and standard deviation and how many standard deviations values are from the mean. We have this shortcut, this notation that gives us all the important information. And your textbook uses this a bit. So when we have a normal distribution, we see a capital N in front of our brackets, and then we have an ordered pair. The ordered pair always gives the mean first and the standard deviation second. So here we see consider x, a variable which is approximately normal with a mean of 3 and a standard deviation of 5. Okay, so what is the mean of the standard of the distribution? So again, the mean is given by the first value. So the mean is 3. And the standard deviation is given by the second value in the ordered pair. So the standard deviation is 5. If we want to know the z-score for a value of 10, we use our formula that z is equal to our x minus our mean divided by our standard deviation. So we'd calculate 10 minus 3 and divide by 5. Plugging that into our calculator, we find that the z-score corresponding with an x value of 10 for this particular distribution is 1.4. Okay, we're going to leave z-scores here for today. We're going to pick up on z-scores again in the next module. And for our next video, we're going to talk about what's called an empirical rule, which lets us quickly approximate the probability of different events happening for standard normal distributions or normal distributions when things are 1, 2, or 3 standard deviations from the mean, when we have z-scores of 1, 2, or 3 nice integer values.